Okay, in this video we're going to look at geometric sequences. All right, this is a sequence where instead of like the arithmetic sequence where you add a certain number each time, that's a common difference and it's linear, this one is exponential. So this is where you multiply the previous term by the same number each time to get the next. So for example, you would have a sequence like 2, 4, 8, and 16, and 32, where you start with 2, multiply it by 2, and you get 4. Multiply that by 2, and you get 8. That by 2, you get 16, and then 32. So this is an example of a simple geometric sequence. And the way the formula works for this is because you keep multiplying by 2 to get the next term, it's an exponential one. Okay, so the way it's defined is Tn, T subscript n, equals A times R to the n minus 1. Okay, and R is defined as the common ratio. A is the first term. So the common ratio is the number that you multiply by to get the next term. Okay, so for example, for this one, T1 is going to be equal to A times R to the 1 minus 1, which equals A times R to the 0. And we know that anything to the 0 is just 1. So that just becomes A. So this is convenient again that we have A is the first term in the sequence. Okay, and T2, well, that equals A times R to the 2 minus 1, which is A times R. Okay, so it's R times the first term. T3 equals A times R to the 3 minus 1, which equals A times R squared. And that is just A times R times R. So the previous term, T2, times R to get the next term. Okay, so that's what this sequence is. This is a formula for it. This is for the general term. And let's go back and look at the example here. So you've got the example of 2, 4, 8, 16, 32. If you look at that, the way you can get the common ratio, 2, 4, 8, 16, is take any term and divide it by the previous term. So to go from term 1 to term 2, you'd have to multiply by the same number that you multiply by to go from term 2 to term 3, and from term 3 to term 4. So if you know the terms, to figure out what you multiplied by, just take term 4 and divide it by term 3. Term 3 and divide it by term 4, and term 2, and term 2 divided by term 1. Okay, so R equals T2 over T1, which equals T3 over T2, which equals T4 over T3, which equals, and so on, that same pattern. Okay, so in this case, you'd go R equals 4 over 2, which equals 8 over 4, which equals 16 over 8, and that all equals 2. So if it's all the same number when you go through this, then you have a geometric sequence. Okay, and for this one, since R equals 2, and A, there's T1, equals A equals 2, you can write that Tn equals 2 times 2 to the n minus 1. Okay, so A is 2 and R is 2 in this one. Now this one can be simplified. Okay, so that equals 2 to the 1 times 2 to the n minus 1. When you multiply exponents, you can add them when the bases are the same. So this is 2 to the n minus 1 plus 1. There's the n minus 1 from there, add that exponent, and that becomes 2 to the n. So Tn in this case, the general term is 2 to the n. Okay, another example is, just a quick one here, is imagine you start with 3, and then you go to 6, and 12, and 24. Well, on this one, A equals 3, and R equals, well, 6 over 3, which should equal 12 over 6, which should equal 24 over 12, and that all equals 2 again. So our formula for this geometric sequence is Tn equals 3 times 2 to the n minus 1. And that one can't be simplified because the bases are not the same. 3 and 2 are different. So that's it for that one. All right, so now what if you're given a sequence where you know 2 of the terms are not consecutive, and just like in arithmetic sequence, you want to figure out the formula for the sequence. Okay, so say you're given T5 equals 567 and T8 equals 15,309. Okay. Well, in this case, this is 3 jumps from T5 to T8. So you're going to multiply by R 3 times. And when you do that, that's going to give you R cubed. Okay, so to go from T5 to T8, you're going to be multiplying by R 3 times. R times R times R is R to the 3. Okay, and I'm going to show you that here. So T8 divided by T5 equals, in general, A R to the 8 minus 1 over A R to the 5 minus 1. Okay. A R to the 7 minus 1, or 8 minus 1 is 7. Then A R to the 5 minus 1 is 4. The A's cancel out. And when you divide with exponents with the same base, you subtract. So that becomes R to the 3. So now that we know that T8 divided by T5 is R cubed, we could do that for any 2 terms just by looking at the difference between them. The difference here is 3, so it's going to give you R cubed. If it was T10 divided by T5, then it would be R to the 5. Okay, so now we're going to take these 2 terms and put them in here. So R cubed equals T8 over T to the T5, which equals 15,309 divided by 567. And when you do that in your calculator, you end up with 27. So if R cubed equals 27, then R must equal the cube root of 27. Okay, so instead of square root, it's cube root. So you use the button on your calculator to figure out what this is, a cube root, and you get R equal to 3. Okay, so for this one, R equals 3. And you can do that in your head. 3 times 3 is 9, times 3 is 27, but sometimes not so easy, so you should figure out how to use your calculator for that. Okay, so now we know what R is. We don't know what the first term is. So there's a couple ways of doing this. And one is to plot the point. So Therefore, you've got Tn equals a times 3 to the n minus 1. We just don't know what a is. And to find out what a is, we could sub in the point or the term T5. T5 equals 567. Sub in 5 for n, 567 for Tn. So 567 equals a times 3 to the 5 minus 1. So 567 equals a times 3 to the 4. Okay, and so a equals 567 divided by 3 to the 4, and that gives you 7. So now you know the full formula. Full formula is Tn equals 7 times 3 to the n minus 1. Okay. Another way you could do this, okay, or, and this is probably shorter, if you know, and we've talked about this before, if you know the term 5, which you do in this case, then instead of putting n minus 1 for the first term, you could put a n minus 5 and plug that in. Okay, so that would be the fifth term. So you could write that Tn equals, instead of a, put in the fifth term, which is 567 times 3 to the n minus 5. And that would work. And at this point, you would just do 567 times 3 to the n minus 1 times 3 to the negative 4, because if you add those exponents, you'll end up with n minus 5. And then you'd write 567 times 3 to the negative 4 times 3 to the n minus 1 if you want to get the same formula. And when you work that out, 567 times 3 to the negative 4, that ends up being 7. 7 times 3 to the n minus 1 gets you the same answer. Okay? And that's it for geometric sequence.